All right, hello everyone. Thank you for joining this week's CSI Secrets community call. It's July 8th, and this meeting is under the CNCF Code of Conduct guidelines, so please be respectful when having conversations with others. With that, looks like we've got a pretty light agenda here. In fact, no items as of yet, but I know Micah had mentioned that he has a demo that he would like to show to the community.
Yes, and I am ready.
He is ready. Okay. So with that, I won't even bother to share the our doc here. So let me go ahead and bump you up, Micah, to make you a presenter here.
Thanks.
And I guess before you jump into that, Micah, is there any other items that anyone wishes to chat about or discuss, either from last meeting, any follow-ups or anything? Okay, I'll take silence. No? Or okay,
yeah,
sorry, go ahead, Tom.
I was just gonna say, I don't think so. I think we've Anisha's been out this week or something, but that next week I think is when we're scheduled to do another release of the driver. I think it's next week. But yeah, another release should be coming pretty shortly, I think before the next meeting. So
okay, all right, thanks for that update, Tommy. Okay, so with that, hey, the floor is yours, Micah. Show us what you got.
Great. Let me start sharing my screen. So let's do the whole screen. All right, you can see my screen?
Yes.
Great. So basically, this is kind of based on the PR that I have out, and I saw that there's been some comments on it, so I will get to those shortly. But the basic idea, where's my view? Oh, here it is so this is leveraging the token request functionality in CSI. I think this is really, again, this is for most people here probably already seen this, but I just want to kind of show something I think that can be done that's really cool with this new functionality. Basically, it enables a CSI sidecar to not need its own identity to do stuff for pods, right? Like you're passing the token that is that the kubelet acquired from the API server for that specific pod. And the great thing about that is kubelet is by nature of the node authorizer and node admission controller, the node can only request tokens for pods that belong to it. The kubelet can only request tokens for pods assigned to that node. So I can't get a token for, say maybe some administrative pod on some other node. So I get these great authorization boundaries built into token request. So when kubelet passes on this token request, like token, well, this I just kind of diagrammed for myself just to get my head around the flow. Basically, kubelet requests a token from the API server, and that's again scoped down so that it's only for that pod. API server is making sure it's not for a pod on another node. Kubelet is requesting, in this sense, to this, I'm calling this IRSA agent, but that's basically secret store provider, right? And in this model, you can sort of think of this, what I've modeled as this IRSA agent and the secret store plugin provider that I wrote as the same component, just because they effectively have the same boundary here. So the plugin then requests from what I showed before. There was just a CSI sidecar. Now what I have is basically a small server that can run somewhere else in the cluster. So the CSI sidecar can now, or the provider for the secret store provider can request from a local server and say, hey, I need something in exchange for this token. Now this server that I have running has mappings of AWS IAM roles to service accounts. So when a specific token for a specific service account is given, this server then can validate that token, can call token request against Kube API server. It could do it all in memory and do, OIDC validation on the server itself. But for now, I'm just calling Kubernetes token request because that tells me, is it valid? Is it signed by the API server and everything else there? Then what I have happening is this server is calling AWS STS assume role. So that's basically a way to use its own identity that the server has to get credentials for some other role. And it knows this based on the mapping that's given to this server. So right now I just am supplying the mapping of service account to IAM role via a simple config file that could easily be changed to a CRD or other stuff later. So it gets back these role credentials, and then it can pass those role credentials on back to the secret store plugin provider, and which gets passed back to secret store and gets mounted and gets into the pod, right? And in the end of the day, that gets mounted as an AWS config file into the pod, right? So that's great. Like we get credentials down to the pod. And I demoed this largely last time without the server side. So it's just the agent kind of doing everything, where the agent was talking to STS. The advantage that I have here with this server that's kind of cool is that AWS STS has a feature where you can assume, when you call assume role, you can provide what are called session tags. These are key value context pairs that get injected into the AWS session token. So what I'll show really quick is when I have, so I have this is my, again, I have this running in a cluster, but I'll just demo it locally. So I have a little server running that's essentially this request server. It has its own IAM credentials that can assume another role. And this, I have a little client here that is, let's see, where's the client? Okay, so this client has a token. I can actually, let me get the token. I have a README, and this will be easier than trying to retype it all. So this token basically is a little hack script. This is basically mimicking kubelet getting a token for a pod, right? And so I'm just picking core DNS in this case. It's making a token request just like the kubelet would and getting back a token for, in this case, the core DNS pod. So if I call get hack token, get token, I should, oh, wrong, hold on. I'm in the wrong place. I have my context limits up here. Okay, so I have a token. There's my pod UUID. And now what I'm going to do is use that token to write credentials. Basically, I have a small client that's basically, again, acting like that, like the secret store plugin. And I'm going to write those credentials to a file. Okay, so if I assume config, oh, I'm against the wrong API server. I have two API servers. Well, I can actually show this really quick. So if I get pod all namespace, wide all namespaces. Okay, so I have a COPS cluster, and it has all the components here running. What I've got is basic. So here's an example really quick. Is I've got the server running, and when I call assume role, I do these tags. So I say namespace, kube system, service account UID, pod UID. So all these key values are stored in the session token for this AWS session. when I have those credentials, I can do things like, hold on. Nope. Oh, I just cleared it out. Okay. Well, either way, I can show you what I ran before. Basically, what happens is, and these credentials are no longer valid, so they're fine to record in the recording. When I call, what I did is on the role that I have, that I assumed and gave down to, in this case, my simulated pod, and what this whole CSI driver does. It has this following, this is the AWS CloudFormation templated IAM policy. What this policy says, and this is based off the docs here, is that someone with this permission, in this case, this role, can only do things where the session context of that role matches the tags in the request. So in this case, I'm saying pod UID and namespace. What this effectively means is each pod, while it's, say, in a service account, and in this case, it's a CorDNS pod. Obviously, the CorDNS is not really talking to AWS Secret Manager. But what you can do is, you can imagine this for any other pod. When a pod gets this set of AWS credentials, that pod can talk to Secret Manager, but all the requests when it talks to Secret Manager must have the AWS tag key pairs where that key pod UID, that string pod UID, where the value matches the actual pod's UID and the key namespace equals the value of that pod's namespace, in this case, kube system. So when the pod gets an AWS credential, if it tries to, say, in this case, I have this Secret Manager policy. If I try to call, and this is kind of small, I'll increase this font size. When the pod tries to create a secret, so this is an AWS CLI config call using those credentials, using a secret, name, the secret name is Kate's namespace secret dash CorDNS with a description. The secret value is quote super secret. I put the request tags as key namespace value kube system, but not really. And I get an access denied. But when I do here again, key namespace equals value kube system, I'd also get an access denied because I don't have that second condition. When I ran it again, and I set here the tags to namespace, kube system, and pod UID to that actual pod sessions UID, I can actually, so these creds are actually valid. No, that's the token, just kidding. That pod UID, I actually can create the secret. So basically what this effectively does is I'm leveraging Secret Manager to distribute AWS creds around. But because I have this intermediate server where I can set these session tags, I can do cool things like, oh, I know based on this token that is being passed through Secret Manager, I know all these things about where this token is coming from, and I can add that to my, in the AWS case, my AWS session context, and then do cool things like, okay, if I want to list secrets with that session or for that pod, then I can, maybe only list secret. I can list all secrets, but I might be able to only get and describe secrets that are in my same namespace, but I can only create secrets with my pod UID. So I couldn't maybe delete secrets for some other pod UID, but I could maybe read them. So this gives you like really strong, like you can imagine really strong boundaries around the identities that you distribute to your pods in this system. And it's all leveraging like this token request feature in CSI secret store driver. So that's my demo. It's kind of basic, but it's and it's not totally complete. I don't have it totally running in cluster yet, but I just got this working late yesterday. So I thought it would be cool to show.
Yeah, no, that actually was pretty cool. I got a couple of questions.
Yeah.
The session, what's the TTL on the session? Is that coming from, is that handled from the the API server, or is that
Yeah.
handled on the other side?
It's configurable. So
Okay.
that mapping, I can share my screen again. So if I, again, this is like a very prototype work in progress, but I go to, so I have a struct that I'm basically reading a JSON file here to say, okay, this namespace, this service account maps to this role arm, right? And so again, this is very prototype, but I could do things like duration seconds.
Got it. Okay.
And set the TTL to whatever I want. Right. I could add other things here, like basically anything that I can put into the assume role call, like a policy to scope down that session to a specific subset of permissions or something. But yeah.
And that component you referenced as was it like an RSA? What's it?
Yeah.
Okay. So that's just an endpoint, right? That doesn't necessarily have to be in the cluster.
It doesn't have to be in the cluster. Exactly right. It could be, you could have one for multiple clusters. Right now, I've really written it just to be like one per cluster. But I could easily add, multiple clusters that it could map to, so that, this cluster is associated with this endpoint. And so, yeah.
Cool.
Yep.
Any other comments, questions?
Yeah.
Okay, yeah, go for it, Tom.
I was just the idea here is not necessarily for extending like the AWS plugin to have a way to do like arbitrary pod identities, is that?
Yeah.
My understanding the end.
Yeah, the idea is just that the idea for this demo, like in this project that I'm like playing with, is that you can inject session like key value pairs based on what you want. In this case, I'm doing it all based on the token that's coming in. But I could do other things like add, labels are obviously can come and go on a pod, but I could add label metadata in there too. So that say your pods, like the requests your pods make to say manage, I don't know, something like secrets manager or anything else, right? Like in AWS, need to have the same key value pairs that are in your session. Whether that's the label or the service account name or the pod name or whatever it is.
Yeah, cool. And then, yeah, I think I was one of the last reviewers on the PR. So, feel free to ping me on Slack because I think we're also pretty interested in getting that in because it, like you mentioned, it helps with kind of like node isolation.
Yep.
So, yeah.
Great. Yeah, I'll take a look at the comments and update it.
All right. Thanks, Micah. Okay. I think that's all we have on the agenda. Is there any issues or PRs that we want to take a look at? I can go ahead and share out the list here and let's see if there's anything interesting to chat about.
The only other thing I'll call out to about this, unrelated to the open issues, is that this obviously isn't integrated to the AWS like secret provider yet, but the same type of functionality could be leveraged once token request is there, and then the AWS secret manager provider supports token requests, because then again you get this same type of isolation, but you don't even have to make the AWS API calls. You can just provide it in the it could be part of the provider itself.
All right. Thanks again, Micah. I'm assuming you guys can see my screen. Is there any issues we want to talk about that's out here that may be lingering or need some clarity?
I think some of the newer ones might be kind of like docs issues. Like there's I was just starting this morning to look at the top two, but so notice I think there's maybe timeouts on the Windows tests that are creating failures. So I was going to look in that more today. I think this AWS one was more of a documentation issue in that we have some we have features that are optional that like need to be documented, that you need to explicitly add them.
Okay. And so nothing really critical there. Are there any PRs anyone needs to be have brought to attention? Okay.
I think we have, I think we've got comments out on most of the PRs here.
Okay.
And then, one of them, I think, is, some of them are just blocked on the Windows tests that I mentioned earlier. So.
Okay. All right. So that is it. Super quick call for this week. Is there anything? I guess we can go ahead and wrap it up. We don't have to hang out. Before we do that, is there any other comments or anything anyone wishes to discuss? Okay.
We'll finish up a little note here on Micah's demo. And so, yes, Micah, if it looks right.
Okay.
Or it doesn't look, if my summary doesn't look right, let me know. Okay.
Yeah.
All right. Okay. We will go ahead and wrap things up. Our next meeting, that'll be scheduled 2 weeks from now. So that'll be July 21st. I will be out of office, but I'm sure someone can pick up the moderator and note taking at that time. Yeah, with that, we'll go ahead and end the meeting. Thanks for that demo, Micah. That was actually pretty cool. So, okay, we'll go ahead and hopefully the recording will be out here in the next couple of days, and we will meet again back on the 21st in a couple of weeks. Okay, thank you all for showing up. Catch you later. Thank you.